multiplying algebraic terms. Now I'm going to multiply each of the terms here, and as I'm doing so, I want you to notice if you can see a particular pattern on how to do this. So we got 4x times 2x, we get 8x squared. 6 times 2x, we get 12x. 3x squared times 2x to the power of 3, we get 3 times 2, 6x to the power of 5. Here we have 5a times 2a squared, we get 10a to the power of 3. So you'll notice how we do this. When we're multiplying, we just simply multiply the two coefficients in front of the variable. So for example, the first one here, 4 times 2 is 8. And then you multiply the variables. So x times x gives x squared. Now you'll notice that's x to the power of 1, x to the power of 1. 1 plus 1 gives 2. Here, the next one, we just multiplied 6 by 2 and get 12. And then we have an x there, so it's 12x. This one here, we have 3x squared times 2x to the power of 3. The coefficients are 3 and 2, so we multiply the coefficients. 3 times 2 and get 6. X, so the same variable, but the power, we just add the 2 and the 3 and get 5. This one here, 5a times 2a squared. We multiply the 5 times 2 and get 10. And then multiply the variables a to the power of 1 times a to the power of 2. 1 plus 2 gives 3. So when you multiply algebraic terms, all you do is multiply the coefficients, that's the constant in front of the variables, and then you multiply the variables together. But remember, when you're multiplying the variables, you must add the exponents. Now, why do we add the exponents? Well, let's just have a quick look here. For example, let's just isolate this x squared and the x to the power of 3. So if I go x squared times x to the power of 3, I've got two x's there, x times x. Now that represents x squared. And then I have now times x times x times x. There are 3 x's there, so that represents x to the power of 3. Now, as you can see, how many x's are there altogether? When you add them up, we have 1, 2, 3, 4, 5. So what you do, you add the powers, x to the power of 2 plus 3. So x to the power of 2 plus 3, we get x to the power of 5. So that's why you always add exponents when you multiply them, variables. Okay, so let's now have a look at the rule. Terms can be multiplied irrespective of whether they are like terms or unlike terms. So we're multiplying terms now, not adding or subtracting. Now when multiplying terms, first multiply the coefficients and then multiply the variables. Add the exponents when multiplying variables which are the same. So the variables have to be the same to add the exponents. So let's look at some more examples here. Multiply 5x times 3. We go 5 times 3 is 15. And we have an x there, 15x. Number B, 6x times 2x. So we multiply the two coefficients. 6 times 2 is 12. Multiply the two x's, both x to the power of 1. So it becomes x to the power of 2. 1 plus 1 gives 2. Number C, we have minus 7x times 4. So minus 7 times 4, we multiply the coefficients, gives minus 28. We have the variable x there, so minus 28x. Number D, Now here we have negative x times negative 3x. So negative 1, that means negative 1x times negative 3. Negative times a negative, you know, gives a positive. 1 times 3 gives 3. X times x gives x squared. Number E, 3x squared times 2x to the power of 4. So we multiply the two coefficients first. 3 times 2 is 6. Now we multiply the variables. X squared times x to the power of 4 will give x to the power of 2 plus 4 gives x to the power of 6. So we add the variables, the exponents of the variables there. Here, f, we have minus 9x to the power of 5 times x to the power of 3. So that's a 1 in front of that x to the power of 3 there. So minus 9 times 1, of course, just gives minus 9. X to the power of 5 times x to the power of 3. We add the exponents, so it's x to the power of 5 plus 3, 8. Number G. Now we have 7a to the power of 3 times minus 1a to the power of 3. So 7 times minus 1 gives minus 7. Now we multiply the variables. A to the power of 3 times a to the power of 3 gives a to the power of 3 plus 3, which is a to the power of 6. Number H. Now we multiply the negative 6 and the negative 4 first. So negative 6 times negative 4 will give plus 24. We have a squared there and no variable there, so it's just 24a squared. Number I here. Now, we've got 4 times 2. Let's do the coefficients first. 4 times 2 is 8. Now we have a squared times b to the power of 3. So let's do the variables now. Now you'll notice we cannot go a, b and add these exponents here. Why? Because these variables are different. We have an a and a b. So we cannot collect these exponents. So it just becomes 8a squared b to the power of 3. Number J, now we have 2a to the power of 3b times 4a squared b to the power of 5. So we follow the same rule, the same idea. We multiply the two coefficients. We get 2 times 4 is 8. Now we've got an a to the power of 3, a to the power of 2. Now these variables are the same, so I can add these two exponents and get a to the power of 3 plus 2, a to the power of 5. Now I've got a b and a b to the power of 5 there, so I multiply those. That means b to the power of 1, so 1 plus 5 gives 6, so b to the power of 6. So our answer is 8, a to the power of 5, b to the power of 6. And the last one here, number K. We follow the same rule. We multiply the coefficients. We have negative 8 times negative 5. Now, that will give a positive. 8 times 5, 40. Now we have x to the power of 3 times x to the power of 4. Now, notice the variables are the same, so I can collect and add the exponents of each variable. So x to the power of 3 plus 4 gives x to the power of 7.